Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can set up name-based virtual hosting in Apache HTTP server. So here in this article, we will try to set up a very basic name-based virtual hosting to host two different customers with their content. And we will be doing this using Ansible. So let us see how we can achieve this in this video. So coming to my test environment, I have a Fedora operating system on top of which I'll be installing the Apache HTTP server, and I'll be using a Fedora workstation as a client to uh, access my Apache HTTP server. Coming to virtual hosting, so let us try to understand what is virtual hosting. So virtual hosting is basically a feature wherein a single Apache HTTP server that will be able to we will be able to modify it in such a way that it is able to run multiple websites on a single machine. So this feature is can be enabled using two methods, that is IP-based virtual hosting and name-based virtual hosting. So irrespective of whichever method that you are using to do this virtual hosting for your website, for the end user, it is going to appear as a single web server. Okay. So now let us try to understand about IP-based virtual hosting. So the routing of the request uh, to the correct virtual host, basically like whichever virtual hosts are present, is decided based on the IP address that is present in the requested URL. So basically, like whenever a request is happening, the routing is decided based on the IP address of the request uh, that is present. IP address that is present in the request. So that is how the IP-based virtual hosting happens. Now let us look at the name-based virtual hosting. So in this method, the routing of the request to the appropriate virtual host or the correct virtual host is decided based on the host header that is sent by the client as a part of the request. So basically, like whenever a request is sent, there is a host header set in the request which points to the correct virtual host server name, and based on that, the request is routed to the correct virtual host in the Apache HTTP server. So now let us try to understand about support for host headers. So with the advent of HTTP 1.1 specifications that are introduced in 1997, support for host header has become mandatory for compliant web servers. So this feature, making it compulsory to have a host header in the web browsers, has made a massive change. So this allowed the servers to host multiple domains on a single IP address. So basically, a single HTTP server was able to act as was able to support a host in multiple domains using this host header feature. Okay, so this makes name-based virtual hosting feasible and efficient. So since then, once the HTTP 1.1 ensured that the host header is made mandatory, since then all the major modern browsers and clients support the host header. So rendering the need for multiple IP address for different domains unnecessary for general web servers. So basically, with the advent or with the usage of the host header in the request, the IP-based virtual hosting has been rendered useless. Now, also, modern web servers can efficiently handle domains using name-based virtual hosting, which is more resource efficient and scalable. So that is why, it is recommended to use name-based virtual hosting rather than going for IP-based virtual hosting. Now let us try to understand about the high-level architecture for the name-based virtual hosting that we are going to implement in this video. So as you can see, like we have a Apache server. So this is our Apache server in which is having a single IP address. So this single IP address is going to point to two different domain names, that is FQDN1 and FQDN2. And these requests that are coming from this workstation to this IP address, the requests are routed to the virtual host based on the host header that is set in the request. So host header will either contain the FQDN1 or FQDN2, and based on that the request is routed to the appropriate virtual host, that is virtual host 1 or virtual host 2. So this is the high level architecture that we are going to implement in this video. Now let us get into our procedure to implement this feature. So as a first step, we need to ensure that you have a Apache HTTP server installed and running with the default configuration. For that, you can follow my blog or tutorial like how to set up Apache HTTP server using Ansible for the same. Optionally, like you can have the mod underscore info and mod underscore status modules enabled with restricted access for future reference in case we need to do any troubleshooting of Apache HTTP server. So for that, like how we can enable, how to activate and configure Apache HTTP server modules for status and configuration, for follow this article. Okay, so this is how we will be able to set up our basic Apache HTTP server. So for me, so let me show you my remote server. So I'll show you whether my Apache HTTP server is currently running with the status. So currently my Apache HTTP server is running. So if your default Apache HTTP server is up and running, you should be able to get the default page for that domain, that is hello customer one. Okay, so this is the domain for that for this server, for this remote server. So this is the fully qualified domain name for this server, wherein I have Apache HTTP server installed, and it is hosting the default page, that is hello customer one. Now let us try to go to our next step, that is creating virtual host. So here, like what we are going to do is we are going to create two different configurations for two different customers. We will be using name-based virtual hosting method to host two different websites. Okay, so let us first update the host variables with the configuration and data directory for each customer as shown below. Okay, so let me show you the host variables. So here you can see this is the configuration data directory for the customer one, and this is the data directory wherein the content will be hosted for customer 2, and this is going to be the config directory for customer 2, and this is the data directory for customer 2. Okay, so these are the variables that we will be further using in our roles, which we will be defining further. Now let us go to our next step, that is update Apache HTTP server configuration. So as I said, like we are going to create two different configurations file for named customer1 .conf file and customer2 .conf file, and which these two configurations file will include the virtual host configuration for each customer. So these configuration files will be further included using the include directive in the main configuration, that is http.conf file. Okay, so let me show you that configuration. So for that we need to go into the role Linux configure underscore httpd. We have wherein in the files we have defined two files, that is customer1.conf file. So this is the virtual host configuration using the name based virtual hosting. So we have this IP address of the remote host wherein the Apache HTTP server is installed, and this is the port on which we are listening. And for this virtual host, we are defining the server name as customer1.linuxserver.stack.com. So this is the subdomain under this fully qualified domain name, which will be acting as a virtual host for customer one data. So this is the root directory, document directory for customer one. And the directory section, like we are defining that this directory should not be overridden, and it should be granted access for all. By default, if you look at the HTTPD configuration, let me search for deny. So by default, if you see the directory slash is not allowed to override, and it is denied access. So if you try to access this without this configuration, without the directory configuration, you will be getting the access denied error. So that is why, like, we need to do this configuration so that only this specific file system on the server is granted access. Similarly, like we are doing it for customer 2 with the virtual host configuration, that with the server name customer2.linuxserver.stack.com, and with the document root as this var opt data customer2, and this is a directory which will be serving the content for which we are giving access to all. Okay, so now we have looked at the configuration. So as I said, the default configuration of HTTP servers has deny access to the entirety of your server's file system. We must explicitly permit access to the web content directories in other directory blocks as shown below. So this is the configuration that we have just tried to understand for each customer. And also, once these two configuration files have been created, we need to update our http.conf.j2 template file to include these two configuration files at the end of file. So if you go to the configure templates h2 and go to the end of the file, like you will see that we have included the two customers configuration files, which will be loaded or loaded onto the remote Apache HTTP server. Now we will update the task main.yaml file to ensure that the configuration and data directory are created for each customer, and also copy the virtual host configuration file to the config directory for the respective customers. So in the task main.yaml file, so what exactly we are doing is, we are first updating the main configuration file with the template, and then we are ensuring that the config directory exists for each customer, and then we are ensuring that the data directory is present for each customer, customer 1 and customer 2. So these are the variables that we have already defined in the host variables, which will be replaced over here. So once the config and data directory is present, we are uploading the customer 1 configuration data configuration to this location config directory, and we are uploading the customer 2 virtual host configuration to the following directory. Okay. So we have looked at the main.yaml file. So for name-based virtual hosting, we need to have our Apache HTTP server to be DNS resolvable to two different host names. So for this, basically, like you can configure your DNS to route to DNS to resolve to two different domains, which are subdomains of the main FPDN. But in our case, like we do not have a DNS, so what we are doing is we are working on a local setup. As we are working on a local setup, we will be updating our workstation machines etc host file to uh, to DNS resolve to the following FQDNs, that is customer2.linuxster.stack.com and customer1.linuxster.stack.com to the Apache HTTP server IP address as shown below. So let me show you. So this is the workstation in which we have this following IP address for our remote Apache HTTP server, which is having the fully qualified domain as linuxser.stack.com, but we are appending two more domains, that is customer1.linuxser.stack.com and customer2.linuxser.stack.com. So this is what we need to do in the configuration. Now let us go to our next step, that is step 4, create static content source. So as a part of this step, like we will be creating a static content on our workstation, which will be acting as the source of the static content for the web server. So this static content we are going to basically upload to our Apache HTTP server's document root, which we have defined for each customer. So here is a directory structure for our data directory. So for now, like you can ignore the secure .html, but this is going to be used for later when we try to secure the Apache HTTP server content. But for now, like you can just create a customer1 directory with index.html and customer2 directory with index.html, which contains the hello customer1 and hello customer2 content. So now let us go to our next step, that is create Linux static deploy HTTP role. So here, like we are creating a new role named Linux static deploy HTTPD, which will be used to deploy the static content from source directory on the workstation to the Apache HTTP server's document root directory for each customer. So here, so let me show you that role. So this is the role wherein we are deploying the static content to the following data directory for customer 1 from source to destination, and we are deploying the static directory for customer 2 from source to destination. Now let us go to our next step, that is step 6, update the Linux setup httpd.yaml file. So this is basically the playbook which will be using in order to execute our roles. So in that we have just added the Linux underscore static deploy underscore httpd role with tag as the name of the role. Okay, so that is what like we have updated in our Linux setup underscore httpd.yaml file. So once that is done, it is time now to deploy our static content. So let me copy this instruction and let me open my terminal. So here, like, we are executing the Linux playbook, that is Linux underscore setup underscore HTTP with the following tag, that is Linux underscore static deploy underscore HTTPD, so that only this specific role gets executed, which will deploy our static content. So my static content is already available in the following location: where opt data customer 1 and where opt data customer 2 on the remote server. Now let me clear my screen. Once that is done, the next step, that is step 8, is to execute the playbook rule to reconfigure and restart the Apache HTTP service. So here, like, we are going to now update our configuration. So we are going to update our configuration using the following role, that is Linux underscore configure underscore HTTP. So this is going to upload our configurations for 2 customers, and also it is going to update the http.conf file with the include directives. So our virtual host configuration has been updated and the HTTP configuration has been updated. Basically, it has those 2 include lines if we look at it. So if we go on to the remote server and cat for etc httpd conf http.conf file, so it has the following 2 include lines to include our virtual host configuration. So this is the configuration for customer 1 and this is the configuration for customer 2 that we have updated just now. So once that is done, let me clear my screen over here. Once that is done, it is time to restart our HTTP service. So for that, we will first stop the HTTP service. So we are using Linux underscore stop underscore HTTP to stop the HTTP service. So HTTP service is stopped, and then we are going to start the HTTP service using Linux underscore start underscore HTTP. So our configuration is updated. Now it's time to validate our applications. So in step 8, like, what we are going to do is we are going to validate our customer data for each customer, that is using the custom domain names, that is customer1.linux.stack.com slash index.html, which will provide us with the data hello customer1. And for customer 2, it is going to be customer2 linux.stack.com slash index.html, that is going to provide us with hello customer2 output. So this is how, like, you will be able to implement your name-based virtual hosting in Apache HTTP server. So this is all I wanted to show you. Thank you all. Thanks for watching this video, and you guys have a great day.